So our final presentation in this session will be by Ben Runyan from Xilinx. Ben was sure that he was going to be left with no time at the end of the, everyone else would use 6 minutes and he'd have 0, but look at this, you wound up with extra time. Here you go.
Well, thank you.
Take it away.
And of course I got it well under 5, so. So thank you. Just wanted to give you guys a quick overview. We've been actually, as Xilinx, have been doing embedded vision applications for quite a few years now. And it really started with quite a few years ago in our video image processing. We were doing really at 1 megapixel levels with one of our premier partners, Xylon, and actually you can see these demonstrations running next door in the demo room. And it was really focused around driver's assistance and doing a lot of these video analytic kind of algorithms, pedestrian detection and stuff that they've been developing in the automotive team for quite a few years now. We then progressed that family, or progressed the next step to really moving up to 1080p 60 at 2 megapixel sensors. This was a kit we did jointly developed with Avnet called the Zinc Video and Imaging Kit. And that was really to enable 1080p 60 camera pipelines. And you probably saw this morning in the main session when Dave Tokic talked about this anatomy of smarter vision. So this is a whole new campaign we just recently launched at Xilinx. And it's really focused around 3 fundamental tenets. The first tenet is real-time analytics in imaging applications. On the other end of the coin, it's the 4K immersive displays occurring on the display side of things. And then, of course, you got to connect these two in the middle via various transport technologies, such as video over IP, or in this category, we also consider very high-end complex encoding applications such as HEVC and H.265 encoding going on as well. So there's actually a whole lot of new content that was put up on our webpage, so I encourage you to go off and check the website. That's where you can get a lot more background on it, and a background that talks about all the applications that we believe we're helping drive into smarter applications. Now, in order to enable these 3 tenets, you really have to have 3 main pieces to drive this. You have to have the IP, you have to have the tools to run it on, and then you got to have, of course, silicon to run that on top of. So this is where one of the new platforms we're bringing to market right now. It's the Zinc 7045 platform that Omnitech developed for us, and it's capable of handling 8 megapixel and beyond. Actually, it's good up to 16 megapixel, although even up to 32 megapixel kind of scenarios. So it's really taking it to a whole nother end. I know there's been a lot of talk about the 720p and less, but this is really taking it to the other end of how you start going to the really high end of the megapixel range. And so as you can see on this platform here, it's got a variety of interfaces built into it, whether HDMI, it's got SFP cages built into it for Ethernet, as well as SDI interfaces. And that's however you get the sensor information into it, you'd bring that in, and then you'd bring it onto the Zinc processor. And if you're not familiar with the Zinc processor, a family brought out a little while ago, it's a dual Cortex A9 processor with FPGA fabric around it at various sizes, depending on what you need. In this case, the 7045 is about 300,000 logic cells of capability in there. And so moving on to what's on that right now. So today we've actually got a design running with 8 1080p 60 video streams. Sort of gives you the capability and the processing power of what's going on in this. So you can bring 8 1080p 60 video streams into this. You can deinterlace them, you can scale them, and then basically put it up onto a video overlay. So what are we going to do with the next steps on this? Now you're going to take these kits, the Zinc Video Imaging Kit and some of the IP from Xylon, and we're going to bolt that in as one of the front ends of these inputs coming into this platform. So really sort of try to demonstrate the amount of processing capability you have within the Zinc processor. So in this case, once you've got the image in, really where the power of Zinc comes in is the pixel processing power we have in that video analytics block sitting there. So you've got to do that object segmentation. That's where a standard processor or GPU may have a little more problem doing that. This is where the pixel processing power of the fabric is great. You hand it off to the processor to do the video analytics analysis and put it in the metadata and pass it on downstream. And then the other thing we're showing next door is the tools you got to have to do this, and this is the Vivado HLS and IP integrator tools. Really the point is here is a lot of people in the video analytics are software engineers, and this is the first way to enable software engineers to start using FPGAs as well by enabling some OpenCV libraries on top of that you run it through our HLS tool, and this will map it down into RTL for you. And we got that demonstrating next door. So in the end, the Zynq, we actually feel this is really the perfect platform for driving a lot of this smarter vision that we have of, across all these different applications.
Any questions for Ben? We'll give an extra minute or two since we're a few minutes ahead of schedule. Questions for Ben? All right, well then I'll start with mine. I'm sorry, go ahead.
Is the Omnitech design, is it sold as a single piece of IP, or is it split between software and fabric, and are they bought separately, or as a package?
The current solution is running mostly on the fabric. It does have some of it running up on the processor. That will continue to evolve as we start putting more and more capability, audio decoding and other capabilities up on the processor as well. That's sort of the next steps.
Okay,
Yeah,
purchase
but
directly with,
You
purchase that
purchase it
directly?
directly from them, depending on how many channels of capability. It's $10, $20, or $30,000 for it. It's for the capabilities, the amount of processing power. It's actually quite a good deal.
Thanks.
Any other questions for Ben? So I have a question, Ben. I think you very briefly alluded to HLS, high-level synthesis tools. Traditionally, the way if you wanted to use an FPGA as a processor, you had to be prepared to do register transfer level, Verilog, VHDL design, and as you mentioned, that's not a sort of normal skill set for people who understand vision algorithms. So now you guys have high-level synthesis. The idea is you can generate the RTL automatically from C. A lot of people are very skeptical about high-level synthesis. It's a technology that's been talked about for decades and has never really delivered. Is there reason to believe that it's actually delivering now?
Yeah, well, that skepticism is well received. It's, I guess, been probably over 20 years now that it's been in development. And about 2 years ago, Xilinx acquired a company called AutoESL. And the reason we did acquire them at the time is that we felt the technology had finally matured to that point. We also knew that we were going to be bringing out this processor-based family, and we needed to make life friendlier for software engineers. And that critical piece of that is you've got to be able to get from C down to RTL to be able to use the power of the FPGA fabric. And so, yeah, we actually find in a lot of these applications, and actually with some help from the other arm of Jeff here with BDTI, that benchmarking this, that when you did map it down, you took C down to it, if you had a hand-coded RTL engineer, yeah, they can get in there, and if they do it themselves, of course, they can probably do a little bit better job of it, but it's probably within 5, 10, 15% of what hand-coded RTL would be. And to be honest, dramatically faster to do it through the tool, because you can do that, but it's going to take you a lot longer. Yeah.
Yeah, thanks, Ben. I was kind of leading question because my company did this benchmarking for Xilinx a couple of years ago, and we found for these kinds of algorithmically oriented problems, the HLS tools, at least some of them are really remarkably effective. Was there another question? Yeah. Can you get the mic?
So, I mean, that's pretty fine in terms of doing the RTL level synthesis. How about optimizing memory bandwidth? That's a whole different challenge, right?
The memory is always a challenge, and actually that leads back to Matt's question. One of the best things coming out of this Omnitech design, to give you guys a feel for the amount of memory bandwidth going on in that design with 8 1080p 60 video streams, there's 75 gigabits per second, or gigabytes per second going in and out of memory there. So that's the other beautiful thing about that platform is it's got a full by 64-bit, 1866 megabits per second bus running on there. So it's got a very maximized on the memory piece. And that is the biggest challenge, but what comes with the IP from Omnitech is a very robust VDMA to handle that in and out. So it's got about 40 VDMA accesses going in and out of memory. So yeah, any video or imaging design, the memory accesses can be critical.
Yeah, but the real issue in any kind of video algorithm is not to move the memory to DDR in and out, but keep as much as possible on chip. And how do you do that? Is there any special tools you support for that, or is that something people have to figure it out?
Okay, so you're talking about streaming from block to block to block. Yeah, generally in the imaging piece of that, a lot of that, actually most of these designs that we've done have kept the imaging piece of that in streaming, so it streams from block to block to block. So that's, I don't know if there's, it's a good question of exactly, is there anything special we do to do that? Actually, I don't know if you saw Jose Alvarez's presentation earlier, he'll be over here at the booth next door. He'd be a great guy to tie into that directly. The other part I have, when I usually get up to these 4K, 2K resolutions in the broadcast world and stuff, you do have to do the buffering and image buffering, and that's also another major challenge is can you get enough bandwidth to buffer all these 3 gigabit per second streams? So yeah, that's both sides of that coin. Yeah, they're both very much challenging. The memory is the big piece.
Great, thank you very much, Ben. Very, very informative. Thank you.